Hello and welcome to Trig class. I'm going to go through some notes from lesson 1. A lot of this you probably already know, but I'm going to walk through this handout anyway. Chapter 1, Angles and Trig Functions. Our objectives for this section are to recognize and use the vocabulary of angles, to use degree measure, to use radian measure, to convert between the two, to draw angles in standard position, find coterminal angles, find the length of a circular arc, and find the linear and angular speed described in motion. First, they start off very, very basic. An angle is formed by two rays that have a common endpoint. One ray is called the initial side, the other is called the terminal side. An angle is in standard position. Now, this might not be anything you've heard. This might be new to you. You might not have heard it before. An angle is in standard position if its vertex is at the origin of the rectangular coordinate system and its initial side, there's its initial side right there, lies along the positive x-axis. This is a positive angle. It's going to have a positive measure. This angle goes counterclockwise and it's going to have a negative measure. This one might be, let's see, there's 90, a little past 90. This one might be something like 100 degrees. And this one might be something like negative 100 degrees. So we can have positive angles and we can have negative angles. When we see an initial side and a terminal side in place, there are two kinds of rotations. Positive angles are generated by a counterclockwise rotation, and negative angles are generated by a clockwise rotation. So be sure you get those positive or counterclockwise, negative or clockwise. I may have said that backwards just a minute ago, but this is clarifying it right here. An angle is called a quadrantal angle if its terminal side is on the x or y axis. So if it's 90 degrees, 180 degrees, 270, 360, if I go one more past 360 and 90 makes 450. So we can have quadrantal angles. Those are angles that have their terminal side is on an x or y axis. Measuring angles using degrees. Angles are measured by determining the amount of rotation from the initial side to the terminal side. A complete rotation is 360 degrees. An acute angle is less than 90. A right angle is exactly 90. An obtuse angle is more than 90 but less than 180. A straight angle is 180. Measuring using radians. An angle whose vertex is at the center of the circle is called a central angle. The radian measure of any central angle of a circle is the length of the intercepted arc divided by the radius. So theta is equal to the arc divided by the radius. We'll talk more about that formula in a little while. 1 radian, okay, y'all know a circle's 360 degrees. They also measure these things in radians, and one complete circle is called 2 pi radians. 360 degrees is the same as 2 pi radians. 1 radian is the measure of the central angle of a circle that intercepts an arc equal in length to the radius. So if the radius is r and that little arc length is r, and you divide r by r, you get 1. We consider an arc of length s on a circle of radius r. The measure of the central angle, theta, equals s over r. Put that in your notes. We're going to use that in a little while. Example of computing radian measure. A central angle theta in a circle of a radius 12 feet interprets an arc length of 42. So r is 12. Arc length is called s, is 42. They're both measured in feet. We want to make sure that happens. We're going to put them in the formula. Theta equals s over r. We divide and we get 3.5. So the radian measure is 3.5 radians. Okay, just stick it in your calculator. 2 ratios that you need to know. You're going to do a whole lot of this. You're going to convert from degrees to radians, and you're going to convert from radians to degrees. And this is what I always tell people. If you have 60 degrees and you want to convert to radians, then you need to multiply by one of these ratios. And you want the ratio to eliminate the degrees. So you need to have, if you want degrees to go away, then it needs to be in the bottom so that it'll cancel with that one in the top. So that puts your pi in the top. So those are going to cancel. 60 goes into 60 once, 60 goes into 180 3 times. So 60 degrees is equal to pi over 3. That's how many radians it is. Now, by the same token, let's say I have 2 pi over 3 as a measure of an angle, and I want to convert it to degrees. Then I need to multiply by the ratio that's going to eliminate the pi. The pi is in the top. I better multiply by the one where the pi is in the bottom. They cancel. 3 goes into 3 once, goes into 180 60 times. 2 times 60 is 120, and we're in degrees. So that's how you do your conversions. Well, be sure you mark those down. You're going to need to know those, and you're going to need to know how to use them. Here are some examples. We just did 60 degrees. Let me do a couple more examples for you. Let's suppose that we have 270 degrees and we want to convert that. Then I'm going to have to multiply by something that's going to eliminate the degrees. So it's going to be pi over 180. What goes into both 270 and 180 is 90. Goes in there twice, goes in there 3 times. So I get 3 pi over 2 radians. What if I have negative 300 degrees? Negative 300 degrees would be an angle that went backwards about that far, 300 degrees backwards. And you convert it the very same way, pi over 180. Let's see, what goes into 300 that also goes into 180 is 60. Goes in there 3 times, goes in there 5 times. So that's negative 5 pi over 3. Now, we do the same thing. We're going to convert, let's say we have negative 4 pi over 3 radians, and we want to convert that to degrees. Then we need to multiply by the conversion factor that eliminates the pi. And 3 goes into 3 once, goes in there 60 times. That's going to be negative 240 degrees. If they give you 6 radians and they ask you to convert that, and there's not a pi in there, you still multiply by that same factor, 6 times 180 over pi. And you're going to do that, you're going to come up with a decimal. You're going to say 6 times 180 divided by pi. And there's a pi button on your calculator. It's over here under the hat, divided by pi. And if you'll use that, you'll be better off. If you put in 3.14, your rounding is going to be off just a little bit. This is 343.8 degrees. Okay? Okay, the figures below illustrate when the terminal side makes one full revolution. One full revolution is 360 degrees, also called 2 pi. It forms an angle whose radian measure is 2 pi. Here we have one complete revolution, 360 degrees is equal to 2 pi. This is 3/4 of the way. So there's 90, 180, 270. 270 degrees is equal to 3 pi over 2. That's what that one is. 3 pi over 2. This one was 2 pi. Halfway, 180 degrees, is 1 pi. And 1/4 of the way, 90 degrees, is pi over 2. And I'm going to give you a circle. Or I want you to go on the internet and Google unit circle and click on images, and it will pull up tons of these. Print you one out because it has the degrees, it has the radians, it also has some x and y values that we'll talk about in a little bit later on. But you're going to want one of these unit circles, so go on the internet, just Google it, just Google unit circle, click on images, choose one that's user-friendly for you, and print that out. Draw and label the angle in standard position if theta is negative pi over 4. Well, if it's negative, it's going to be going clockwise. and you're going to go 1/4 of pi. Well, I always like to think to myself, okay, that's 0, that's negative pi, that's negative pi over 2, so that's going to be negative pi over 4. So it's going to be about, I always think in degrees, even though I'm working in radians, it's about 45 degrees going backwards. We rotate the terminal side about 1/8 of a revolution. Since it takes 2 pi to go all the way around, and I'm only going 1/4 of the pi, I'm going 1/8 of the entire circle. Draw and label the angle in standard position. Alpha is 3/4 pi. Well, we're a positive angle, so we're going counterclockwise. I always say this is 0 pi, this is pi over 2, and this is 1 pi. So 3/4 pi is 90 plus another 45. That's 135 degrees. It is 3/8 of the way around the circle. Draw and label the angle in standard position. Beta is the angle, and it's negative 7 pi over 4. Okay, so I'm going backwards. There's 0. There's pi over 2. There's pi. There's negative 3 pi over 2. Now I want to write these as pi's over 4. That's negative 6 pi over 4. So I'm going to go another 45 degrees. That's negative 7 pi over 4. So 7/8 of the way around. Draw and label the angle in standard position. It's 13 pi over 4. Well, you know what? 4 goes into 13 3 times. That's 3 1/4 pi. Well, 1 pi would be here and 2 pi would be here. You're going to go around the circle halfway again and then 1/4 of the way. So that is 13 pi over 4. In the figure below, each angle is in standard position, so the initial side lies along the positive x-axis. And they're showing you here, these are examples of unit circles as well. You're going to want that in your notes. These charts that you see here, 1/12 of a revolution is pi over 6 right here. There's pi over 6. If you think it's important to know it's 1/12 of the revolution, then you can write that in. It's probably not going to show up on any of your unit circles. But you know that there's 360 degrees, and if that's 30 degrees, you know that that is 1/12 of that. So this chart, if you want to stop the video and copy down the chart, it just goes over some of those major angles that you're going to find on that unit circle. Coterminal angles are angles with the same initial and terminal side, but different rotations. That means if you go around the circle more than one time, it's going to be coterminal. For example, if I draw this angle, this is a 90-degree angle, or it goes to pi over 2. This is pi over 2, 90 degrees. If I come back in and I go a whole trip around the circle and back to that spot, then I've gone 360 plus 90, so I've gone 450 degrees, and I've gone 2 pi plus another half pi, so that's going to be, how many, let me see, 2 pi would be 5 pi over 2 is what I'm thinking, 2.5, yeah, 5 pi over 2, so be careful there. Assume the following angles are in standard position. Find a positive angle less than 360 that's coterminal. Okay, 400 degrees. You're going to go 360. Now, how many more do you need to go? 40. So your coterminal angle is 40 degrees. Negative 135. If you go negative 135, there's negative 90, negative 45 more. There you are, negative 135. What is the angle going this direction? So how far would you have to go? You'd have to go 180 and 45 more, and that would bring you to 225. That's what coterminal means, is if it's in what angle in standard position would end at the same spot. Assume the following are in standard position. Find the one that's coterminal. Well, 13 over 5. Let's see, 5 goes into 13 2 times, with 3/5 left over, 2 3/5 pi. So this is what it's going to do. There's 2 pi, and then it's going 3/5 pi. 3/5 pi. Okay. Well, how many? There's a whole 2 pi. You've used up 3/5. How many fifths are left not being used? Well, 1 2/5. So you take away the 2 pi that you used, and you've got 3/5 left. That's your coterminal angle. Negative pi over 15, you're going to go this way, negative pi over 15. So you're going to subtract that from 2 pi, and you find out that you've got 29 pi over 15 left. Okay, I'm going to pause the video.